Okay, so as we are, so you know that on Friday we will have a quiz only on the topic of quadratic functions. So that would be a good idea if we actually recap a little bit. I will skip the simple questions. We have practiced a lot about simple questions, but let us choose some problems in the book, and I will also tell you some problem on myself, and then we finalize hopefully. So one thing that is extremely important for you to know for the quiz is that if a quadratic function is given, then you should be able to find the domain, the range, the maximum and minimum, or I mean, and then the roots, something like this, and be able to sketch the graph of the quadratic function. Yes, yes. When is the main exam? The main exam is moved to week 13. Please check your school soft. Okay, so let us start practicing a little bit. So I would say that this is probably a good question. Of course, this is not one question, two questions in one. So this one. So you see that the function, the graph shows the graph of a function of this form, x plus a squared plus b, and then you want to determine the constants a and b. Okay, so let us, for example, take the blue one. Forget about the red one for the time being. Let us say that the blue one is the graph of a function of this form, f of x equals to x plus a squared plus b. We want to find what is the value of a and what is the value of b. Okay, one way of solving this problem is what? Can you tell me? So you see, how many unknowns do I have? Two. One of them is a, one of them is b. So I should be able to extract two pieces of information from this graph. Okay? So one way, yes.
Can't you not just like, so since you know, like x squared, you know what that is in smooth, it's like they add the numbers. Like for example, on b, it becomes like x minus one minus one. Like I mean x minus two squared minus one. Like I'm not explaining.
Yeah, you are right. I mean, you are thinking about, but the problem is that you don't have the original graph. Yes. But you are saying that the original graph is probably y equals to x squared, and then you are comparing with that one.
Yeah.
So that's correct. So what you are saying is, if you consider the standard y equals to x squared, which is here, I cannot draw it here, but let me give you a feeling of what do I mean. So if you have something like this, then you consider that the blue graph is a shift along the x-axis. How many units to the right? 2 units. And then one unit of shift along the y-axis down. Yes? And then you remember these numbers we talked about are these shifts. They are related to these shifts. So A is related to the shift along the x-axis and B is related to the shift along the y-axis. But do you remember, for shift along the y-axis, this is more or less natural. If you add, it goes up. If you subtract, it goes down. But for the shift on the x-axis, it is the other way around. If you add something, you expect it goes to the right, but it goes to the left. And if you subtract something, it goes to the right. This one has gone to the right, yes, compared to this original one. I don't like this method here because they haven't told us that this is the graph of this function to compare with which one. I will tell you another method, but this probably will work. So how many shift you see here? So compared with the original x squared function, I have 1 and 2 shift to the right. So what should be a? Minus 2, not positive 2, exactly. So a should be minus 2. And then how many shift you see? How much shift you see along the y-axis? 1 unit, but it goes down, yes? So it should be minus 1. So b is minus 2. Okay, if the problem is a little bit more complicated than that and you cannot understand how many shifts have been done, what can you do? You can read pieces of information from this graph. So for example, you have some exact grid points that the graph passes through. For example, one exact grid point is here. Yes? So what are the coordinates of this point? The x coordinate is 1, the y coordinate is 0. So what does it mean? It means that if you consider this function f of x equals to x plus a squared plus b, and then instead of f of x, let me write y as I usually do for functions. And then we say that one point is which point? The point with x coordinate 1 and the y coordinate 0. I see through the graph that this is on the graph. So what does this mean? It means that the coordinates of the point satisfy the equation of the function. So it means that if you put 0 for y and if you put 1 for x, this should work. This is one possible equation. But then you see that I have two unknowns. This is one piece of information. So one piece of information is in general is not enough to find two unknowns. So I need another point that I can read it exactly from the grids. So which one do you think is a good choice? For example, this one seems to be a fair one. And that one also good. So it doesn't matter probably which one we choose. I don't know which one. This, if you don't mind, let me choose this one this time instead of choosing it on the x-axis again. So what are the coordinates of that point? The x coordinate is how much? 0, and the y coordinate is it 4? 1, 2, I see it is 3. Yes? So it is 0 and 3. So another point is 0 and 3. So what does it mean? It means that if I replace y with y value and I replace x with x value, then that also should work. Okay. So what happens? So for example, here I have 0 equals to 1 plus a squared plus b. And here I have a squared because a plus 0 is a squared plus b is equal to 3. So how can I solve the system? You see, I told you I would not ask you directly questions from the system, but in any way, I should be able to find this. Do you have any idea how to solve this? Yes?
Can we add everything?
If we add, nothing is eliminated. Do you remember I told you in the systems, the strategy to tackle any system is to get rid of one of the variables at a time. So instead of adding, for example, what can I do? I multiply by a minus sign and then add. Or if you want, we can subtract. So let me just multiply this by minus sign. And then add this one to that one. Minus 3 plus 0 is minus 3. And then b and b are cancelled. So I will have 1 plus a squared minus a squared. Yes? And then I start solving it. Solving it is not hard. So it's minus 3 is equal to, do you remember the first one squared? 2 times the first one times the second one squared, but I have a minus a squared at the end. So this one and that one are gone. I move this to the other side. So minus 4 is equal to 2a. So what is a? Minus 2. Okay, so you see this is much better and faster way. We guess these numbers correctly. If a is minus 2, I put it back here and I find b. Minus 2 to power 2 is 4. 4 moved to the other side becomes minus 4. 3 minus 4 is minus 1. So b is minus 4. So if the problem is hard and you cannot understand, unfortunately, you have to do a little bit longer way. But if you can compare as actually Shah did, you can immediately understand what is A and what is B. Yes? To practice a little bit more, let us solve the red one in the shorter way. So what is the red one? Yes? So this point is the minimum point or the turning point. So how many shifts I have done onto the left? 1 unit, 2, and 3. So 3 shift to the left, and how many shift to the downwards? 1, 2, 3, 4. So can you tell me what is A and what is B in this case for the red one? Yes?
A is 3.
A is positive 3 because the shift is to the left. The number should be positive. But now what is the other one?
AB is minus 4.
b is minus 4 because I have gone 4 units down. So for the second one, for the red one, the answers are these. For the blue one, the answers are these. Yes?
How do you know it's like similar to a y equals to x squared?
X is good. That's a good question because you see x plus a squared and plus what was it b. What happens if I start with y equals to x squared and then I change x to x plus a, I get y equals to x plus a squared, and then if I add b units to the b, I get x plus a to the power of 2 plus b. So my starting point is just this function. Yes. Okay. But there is another good question here. So I see I want to wait for you first. And that is this question. I think the question should be a little bit more complete. They should ask you, show that for every value of x, this happens. So in principle, they should mention, show that, not just show that this. Show that for every real number x, x squared minus 3x minus 4 is greater than or equal to minus 25 over 4. Okay, so please have this in mind. If I want to give this question in the exam, I will completely mention these phrases. Show that for every choice of x or for every real number x, x squared minus 3x minus 4 is greater than or equal to minus 25 over 4. Without any explanation from my side, I want to see how you solve the problem. And then, of course, I will come to your help if you can't. Okay, I don't want you to solve it now. I will wait more. But what is your idea? How should we solve this in principle? First of all, do you understand what the question means? It means that it doesn't matter even if you start testing all these numbers, you will never ever find a number for which when you calculate this, it becomes less than minus 25 over 4. This tells you that no matter what you choose for x, even randomly, you can bet your life on it that this number will not be smaller than this number. It's always greater than or at least equal to this number. So how should I prove this? This is a very good question because instead of asking you directly what to do, they have asked you the same thing that you know very well, but in a disguised form. So what they are asking for here? So let me ask you, what type of function is this, everyone? What is the type of this function you see on the left? Quadratic function. So this is telling you, show that this quadratic function is greater than or equal to minus 25 over 4. What they want you to do actually, you want to show what is this, what of this function is this number? Can you say? I cannot explain more because if I tell more, everything will be exposed. Yes? So I'm just waiting for your idea. If you want to solve this problem, what do you do to convince me this is the case? What you write on your paper, that when I read your paper, I am convinced, yes, you are right. I will give up. I will not be able to find any x for which this becomes smaller than that. Now don't do calculations, answer my question. Calculation I will let you do later, but I want to make sure that you are on the right track. What you are doing on the paper now. Everyone is writing something. When you write something on mathematics, either you want to discover the idea, so you don't have a clue, or you know what to do and then you are following what you know what to do. So, Azbullah?
Well, I'm trying to like find the edge number so that the number that you can put in so that it becomes minus 25 over 4.
No, let us say, let me close it. I understand what you mean, but let us say you did that and you find the number that you put in there and it gives you exactly this number, then what? It just tells you that you found numbers or numbers for which this expression is exactly equal to this. But it doesn't tell you anything about if this expression is always greater than this expression, or sometimes greater than this, sometimes smaller than this. There is a word for it. Come on. This is not rocket science. What we learned about quadratic functions. And let me guide you. This number is positive. So what is that? So read it in another way. How do you read it in English? This number is greater than or equal to this. Okay? But read it in a different way. Can you read it?
What do you mean?
When you say A is greater than or equal to B, it means what?
B is smaller than or equal to.
Okay. Third method. Okay. B is the minimum. When you want to prove that this is greater than or equal to this, you need to convince me the minimum possible value for this is this. Okay? So instead of asking, so because you see, this is the difference between E-level and harder questions. If I give you this parabola, if I give you this, and I ask you find the minimum, you can find it. But that's the same question, but you cannot find it. The question is telling you, show that this is greater than or equal to this number. It means show that this number is the minimum of this. This is the same question, ask you in a different way, in a disguised form. Is that right? If you want to show that, so this is another way of reading. This expression is at least equal to this. It means the minimum of this function is equal to this. Yes or no?
Yes.
Okay, now prove it. This is an E-level question now. You spoiled the question. Yes, because this is no longer a C-level question. So I hope that at least you can solve the E part. Remember, how should we find the minimum of a quadratic function? This is the most standard question in quadratic functions. Why I am talking about minimum, not maximum?
Because it's positive.
Yeah, if this one is positive, I told you, remember this picture. If this of this type, A should be positive, and if this is of this type, A is negative. So you see that A is 1. 1 is positive, so you expect that your parabola has a minimum. So it means that show that the lowest height that this parabola can reach to is this number. It cannot go below that. You have to be conscious now why you couldn't understand this connection. My role as a teacher is to draw your attention to it, but you have to teach it yourself. Most of you, I would say that if I ask you to find the minimum, you could find. If you couldn't, it means that you didn't study at all. But if I ask you the minimum, you could find. But if I ask this question in this form, you don't know what to do, you have to be conscious right now. You need to think a little bit, a moment, close your eyes. Why I couldn't understand the connection? Yes, then you will understand. Or hopefully you will understand in the future. Okay, those who solve the problem come back to problem 30. It's a little bit harder version of the previous one. Don't waste your time. If you finished 36, jump back to 30 again. It's comparable to the previous question, but this is a little bit harder.
1.5 multiplied by 1.5 is 2.25.
Yes. Yeah, if you solve 36, don't wait. Go back to 30. What?
In all equations or functions where x is to the second power, do all of them have the same shape? Where the highest?
Not exactly. I mean, it depends. Only x squared, ax squared plus bx plus c. All of them that you can put them in this form are always parabolas. But if the a part is positive, the parabola opens upward, and if a is negative, the parabola opens downward. But as soon as you see the form of the function is ax squared plus bx plus c, the general shape is like that. It can be a little bit wider or narrower, but the general structure of the shape is the same. Yes, please.
The question is to like prove that that is true, right?
Yes.
Yeah. Okay.
Yeah, show that. In another word in mathematics, we say prove that. See why this takes so long. Could you solve this finally or not?
Yes.
So is that number correct?
Yes.
So, okay, good. So what we do, we write y equals to x squared minus 3x minus 4. My goal is to find the minimum possible value for y. To find the minimum possible value for y, what was the method? The method was completing the square. And this is the simple ones, not the hard ones, because this has just one. So do you remember what was the trick? The trick was to write the first two terms, and then you have to add and subtract a number. Minus 4 is also there. I have to add one number and subtract the same number. On the one hand, I am not changing anything. On the other hand, the first three becomes the answer to the complete of a squaring pattern. What is that number? I also told you the rule of thumb.
1.5.
So I will work with fractions because you see the final answer is also fraction. So I divide this number by 2 and then square it, which becomes 9 over 4. So the number that I have to add is 9 over 4, but I'm not allowed to change the problem, so I have to take it off once again. But now what is the benefit of that? The benefit of that is that these three can be combined into a complete square now, which is what? X minus 3 over 2 to the power of 2. So these 3 is here, but this I can check it in a scratch paper or whatever. So minus 9 over 4. Instead of minus 4, I want to write the denominator to be 4. So what should I write? 16. But so this becomes 4 minus 9 minus 16, which is minus exactly 25 over. So what happens? This becomes minus 25 over 4. So the answer to this problem is to say that, okay, I write the left side as a quadratic function, and I do like this. And then do you remember? This number is non-negative. Why? Because this is even. So this is greater than or equal to 0. Minus 25 over 4 is a fixed number. I am adding a positive number to it. What happens? It goes above this number. Yes, so this means that the minimum possible value of y is what? Minus 25 over 4. So this means that the minimum possible value of the left-hand side is minus 25 over 4. If the minimum is minus 25 over 4, it means that this expression is at least minus 25 over 4. So it means that it is either minus 25 over 4 or greater. So that was a good question, because instead of asking you directly find the minimum, they have asked you to do it in that way. Okay, now let us go back. Any questions here? Understandable? Okay, so let us go back to this problem. The problem 30 is the same as the previous problem, but here the shifts were very clear, A and B. A is the shift along the x-axis, B is the shift along the y-axis. But here this is written in this form, and you cannot see clearly how much the shift is. Okay? But now you need to look at this picture. The good news is that this is 1 still. So we can compare it. As soon as this is 1, we can compare it with y equals to x squared. Yes? Y equals to x squared is probably this one, for example. You can compare it with this one. Let us, for example, solve the blue one. Okay, so can you tell me what is the blue one? So what is the equation for the blue one? So how many shifts we have to the right for the blue one? So let me count. 1, 2, and 3. Do you agree? 3 to the right, 1, 2, 3, 4 down. So what is the equation for the blue one? So f of x is equal to, so let me record this. I should write x, how much shift to the right? Minus 3 to the power of 2, shift downwards, minus 4. So this is your function. Yes? But this is not immediately the one that we see here, because the one that they have given us have this form. Okay? So I need to use this to find P and Q. How can I do that? How can I find P and Q? Because the function they have given to us is not in this form. It is x squared plus px plus q. They are asking about P and Q because they have asked about the expression for f of x. If you want to write f of x, you need to know P and Q. But how can I understand P and Q? By simplifying this. Yes? So I say that the first one is squared, 2 times the first one times the second one, plus the second one is squared, but there is also a minus 4 there. If I simplify that, it becomes plus 5. Compare it with this one. What is P? Minus 6. What is Q? 5. Or if you want to, you just write this because they are asking for the function. Yes? The second one is also similar. So if you don't mind, let us skip that. Okay, so there are some questions for practical use in maximum and minimum. We solved only one problem. Do you remember that problem related to the fence and gardening? They wanted to cover more. So let me solve some more problems on this type. Okay, so now this is the question. Let x and y be positive numbers. Let me write real numbers. Be real numbers such that let us say 2x plus 3y is 5. Yes? What is the maximum? What is the largest value that the expression let us say for example 3x squared minus plus 2y squared can achieve, can attain? For which values of x? Values of x and y. Y. For which values of x and y this? So let me see if there is a maximum or a minimum to this function. So it is not a maximum. We want to, what is the smallest value? The smallest value that the expression 3x squared plus 2y squared can attain. For which values of x and y this minimum value, this smallest value is achieved. Or something like this. I hope that you understand what I mean. Okay, let me explain this question, and I will give you more examples of this type today. But let me try to explain this for you. Okay. Yeah, be quiet, please. So here, what does this mean? How many numbers x and y I can find that fits this equation? Infinitely many. Okay? For example, one of them is x1, y is 1, it becomes 5. But one of them is x0, y 5 over 3. One of them is x negative 2, for example. Then it becomes negative 4. I move it there, it becomes 9. Then divide by 3, it becomes minus 3. So minus 2 minus 3 is another one. So there are infinitely many pairs. Let me write some of them for you. I want you to understand what is the meaning of the question. So if I want to write 2x plus 3y equals to 5, one possible option is to put x1, y1. This will satisfy this question. And then I would say, for example, x0, y5 over 3. For example, x equals to minus 2, y equals to, what was that? Minus 2, minus 4, 3. And then I don't want to write all of them. It is not possible because there are infinitely many. So there are infinitely many numbers in this list. Yes? But I want to see which pair minimizes this quantity. For example, this x1 and y1 gives me which number? 5. This one and that one, put it here, it gives me 0, 5, 3 to the power of 2, 25 over 9, so 50 over 9. Let us put these numbers there. So it becomes 4, 12, and this becomes 9, 18, 30. So you see, there are infinitely many pairs here, which give rise to infinitely many numbers here. Okay? The question is that, which number in this list is the minimum possible number? I want you to understand, this is a very hard question if you want to do by trial and error. It is impossible. Yes? You understand what I'm saying?
Yes.
Among all pairs that satisfy this equation, each pair gives me a number for this expression. I want to see that which number is minimum possible value in this list. And it is not possible to find all possible numbers because there are infinitely many of them. So I need to find a way to find the lowest value that one can achieve, and I want to know for which pair I can get that minimum value. Yes?
Is the answer just 0?
No. You know why? Many people say the answer is 0. The answer is 0 if this constraint is not there. So what Hasbulat is saying is that x squared is non-negative, y squared is non-negative. So if I want to minimize this, it is natural to minimize this part and this part separately. If I ask you what is the minimum possible value for 3x squared, what is that? 0. 3x squared cannot go below 0 because x squared is non-negative, multiplied by 3 is non-negative. And if I ask you what is the minimum possible value for 2y squared, for the same reason 0, because y squared is non-negative, multiplied by 2 is non-negative. So in principle, what Hasbulat said has something to think about, because you say this, the minimum level of this one is 0, the minimum level of this one is 0, so the minimum level of the total value is 0. But 0 is attained when x and y are both equal to 0. But 0 and 0 does not satisfy my constraint. So I am not asking you find the minimum value of this. If I just ask you what is the minimum value of this without telling you this, then of course your answer is correct and yes, 0. But now I am telling you, among the numbers, among the pairs satisfying this relation, 0, 0 is not one of them. Among these pairs, what is the minimum possible value for this expression? First of all, I want you to understand the question, and then we will go back and solve it. Is the question clear?
Yes.
Okay. So I told you that my target is to minimize this. Minimizing functions will be a very big part of the next courses, Math 3C and Math 4. But here at this level, if you find the smallest or the biggest value, it means that you have to make it related to the topic of quadratic functions in some way. It seems a quadratic function, there is only one problem here. A quadratic function has one variable in it. You can call it x, you can call it y, but there is only one variable in it. But this expression, even though it's of second power, it's quadratic, but it has how many variables in it? 2. So this is the way that you need to think. Whenever you want to solve these kinds of problems, you have to make it with one variable. And then you can use the properties of the quadratic function to find the minimum if there is a minimum, or maximum if there is a maximum. Okay? So let me review what I meant here. So what I say is that this is my target function. So if you don't mind, let me call it t for target. What is your target function? It is 3x squared plus 2y squared. It is quadratic, so far so good, but it contains 2 variables. I have to get rid of one of them. Which one you want to get rid, it doesn't matter, but I prefer to get rid of y. Okay, so what should I do for getting rid of y? I have to review my constraint. So I write my constraint here, because they are telling me you have to respect this. Okay, if I have to respect this, I make y isolated, because I want to take the y and put it here. So what should I do? I move this to the other side, so it becomes 3y is equal to 5 minus 2x. Then y becomes, I divide everything by 3, so it becomes 5 over 3 minus 2 over 3. Okay? Okay, and then I put it back to this equation. So what happens? The target is equal to 3x squared, yes, plus, I forgot something, yes, there is an x here, I forgot to write the x. And then I put that here, I have a 2, then I have 5 over 3 minus 2 over 3, and x to the power of 2. But now, if I tell you what is this, you will tell me this is a function which depends only on x. So I am on the safe side. I can write t of x. That's it. And then this is an E-level question, but because the numbers are a little bit not very friendly, they are fractions, we have to suffer a little bit. But let us say I give you access to the calculator. Is that clear? So before continuing, because the continuation is more or less the standard problem. So whenever you deal with a maximizing or minimizing problem, do you remember what was the name? Optimization problems. You want to minimize or maximize the target function under some constraint. So that is the idea. You need to understand what your target is. Here the target is directly in front of your eyes. It is telling you you are supposed to minimize this. Okay? But the downside about this is that there are 2 variables in it. You have to get rid of one of them. Which one, it doesn't matter. So you go back to another piece of information in the problem, you found this, and then you say that, okay, using this information, I eliminate y. What do I mean by that? I isolate y, for example. I isolated y, and then put this y in my target function. Then it becomes one single variable function. And then I minimize that. I'm talking about the general strategy. Yes, don't get confused, because sometimes these problems might be hard. Okay, the rest of it, let us calculate. If the numbers are bad, of course, I will allow you to use the calculator, but I think we can manage this in our head here. We have to simplify things a little bit. So what happens? T becomes equal to, and I want to write T of x. Okay, so the first term is very simple. Before multiplying 2, I hope that you haven't forgotten that part, you have to raise to power 2 first. The first one squared becomes 25 over 9. Minus 2 times the first one times the second one. Can you do it in your head? What? No, 2 times the first one times the second one. So what the number I should put here? I put the x1 here. What number I should put here? 2 times, you are killing me. 2 times 5 over 3 times 2 over 3. You cannot calculate this in your head?
20 over 3.
20, yes, 20 over 3. 2 times 5 times 2, 20. 3 times 3, sorry, 9. Yes. And then the second one is squared. What is the second one squared? 4 over 9 x squared. Yes. Okay, that was a very bad example because of the numbers. Of course, the problem is not hard. Okay, so let us continue. So 3x squared, I multiply 2 in, so it becomes 50 over 9 minus 40 over 9x plus 8 over 9 x squared. Yes or no?
Yes.
Okay. So I will continue here. Okay, tell me. Is there simplification needed yet? Yes or no? Yes, because you see 3x squared and the last one are similar. So I have to combine them. So you should be good in algebra. So how should I combine them? The coefficient here is 3. I go to a scratch paper. The coefficient here is 8 over 9. Do you agree?
Yes.
So what I do, I take the common denominator 9. This becomes 27 plus 8, which is 35 over. So this becomes t of x. Extremely bad question, you know. The numbers are very bad, but forget about that part. I will help you with that, or I will give you calculator. But then I write this one, x, and then I write that one. I don't know if I'm confusing you. Can you manage these numbers or not? So hopefully you can. Okay, now the problem is to find the minimum. First of all, do you agree there is a minimum or not?
Yes.
Why? Because this number is positive. So the question, you see, if you remember, I wrote the largest first, then I realized there is no largest. And that was a good decision because there is a minimum for it. Okay. Now let me teach you something else because I'm lazy to work with these numbers. Okay, let me teach you in principle. I don't want you to be able to use this because if I get the formula, if you memorize that, you can solve all these problems very easily. Okay. So, okay. So keep it here. Let us talk about this. This is the power of algebra, you know. If I want to find the maximum or minimum of this function, you remember how to do it? By completing the square. Let us do the completing the square once for all. And then we find the formula for everything. You don't need even to calculate anything else. But the formulas are not in the formula sheet, so probably if you don't remember them. But let us try to do that. Okay, do you remember? I write the function. I'm reviewing this. How can I find the range? I don't know the symmetry line, the minimum. How can I find that? Do you remember? We have to complete the square. But the completing a square was hard when there is a number like this there. You remember what was the first step? Yes? Not divide. Factor out. Yes? We factor out. So why? I factor a out. Okay, I want to see how much you understand. If I factor a out, what should I write for the first term?
X squared.
X squared. Why? Because I multiply back, I get the same thing. But can you tell me what should I write for the second one?
Bx over a.
Bx over a, thank you. So b over ax. Why? Because if I multiply it back, it becomes bx. And what should I write for the last one?
C over.
C over. So far, so good. Okay? And now, what can I do? I can write a, and then I need to complete the square. What was the rule of thumb? Do you remember?
Yes.
So I write c over a here. I need to add something and subtract. What is that something? In a scratch paper, b over a divided by 2. What is this one? No, I don't understand you still. You see, you have difficulties understanding them quite fast. So what can I write immediately?
0.5.
No, 0.5 is for yourself. I don't like it, okay? Just write it in a fraction form.
Maybe b over 2a.
Yes. You should be very quick here. Now, this is a very elementary thing. Every time, don't expect your teacher to explain the trivial things every time. Yes?
Does it matter for it?
Yes, it matters. Yes, because now you ask me what is 1.5 times 1.5. Yes, that's exactly the reason. Okay, so b over 2 over a, I square it. What is the number? B squared over 4a squared. And then I subtract this. Yes? I am doing the same thing but algebraically. And then what happens for the first three? It becomes x plus b over 2a squared. Do you agree? And then the next one, I write c over a with the positive sign first. And then minus b squared over 4a squared. Yes? Okay, now what happens? The problem is finished, by the way. But I multiply a in, do you remember? How should I do that? I multiply a here. Yes? And then I multiply a here. A and a are cancelled. Minus, when I multiply a here, 1a and 1a cancelled, 1a survives. Yes? Okay, so I hope that you agree with me that that expression can always be written in this form. But I can make it a little bit more beautiful. How? Let us do this. C minus b squared over 4a. Can you combine them into one fraction? You should be able. For example, how should I combine them? I have to make the denominators the same. The denominator of this is what? No, the denominator is what?
4a.
No, here.
Oh, 1.
1. I want to make it 4a. So what should I do? I have to write 4ac. Yes? And then minus, this is the same. Do you agree?
Yeah.
And then what happens? 4a the same. This is 4ac minus b squared. Is this formula familiar to your eyes? 4ac minus b squared is what?
The discriminant.
Not exactly. The discriminant is b squared minus 4ac. So if the discriminant is this one, so what is that one? Minus discriminant. Yes, because if you multiply it by minus, it becomes 4ac minus b squared. Yes? Okay, so what I will write finally for you is this. Plus minus d over 4. So this is the formula that any other, high schools in other countries they study. But for some reason, they don't want you to know it because, of course, I understand, because they want you to learn the process rather than memorizing. Because you did the same thing. The reason that you don't feel very comfortable now, because it is algebraically involved. Okay, but you did exactly the same thing without knowing the formula. For example, can you tell me what is now the symmetry line here? What is the symmetry line?
The minimum.
No, what is the symmetry line? Y equals to 2x minus 3 squared plus 5. What is the symmetry line? This is E-level question. 1 second. What is that?
Minus b over 2.
Again, you are making the same mistake. You don't listen to your teacher. Who is knocking the door? Can you open the door? Okay. So what is the symmetry line? Again, I am telling you, if you write 3, you will get 0. This is not symmetry line. This is a number. So what is the symmetry line? X equals to 3. Be careful. If I give you y equals to 2x plus 3 to the power of 2 plus 5, what is the symmetry line?
Minus 3.
X equals to minus 3. If I write x plus 3 equals to 0, do you agree? For the symmetry line? Yes, because that is the same thing. But if you just write minus 3, that is wrong. Okay? Now compare this. You see, I don't know. You need to teach yourself. You have to be conscious about your mistakes. When I ask you this question, you immediately tell me the answer. But when I ask you the same question here, you don't answer me. I don't understand why. So again, not minus b over 2. I have to kill myself, you know. So I told you 3 is wrong. What is the symmetry line? X equals to minus b over 2a. And this is the formula, by the way. If you have it in your mind, you don't need to complete the square every time. Because we did it algebraically, and that is the power of algebra. Because you do it once, and then you use it every time. Yes? Okay. Let me ask you another question. If a is positive, then this is also positive. And then, if a is positive, can I say that y is greater than or equal to minus d over 4a? Here. Can you tell me what is the minimum value for this? I will make the questions very hard this quiz. Yes? So what is what is the minimum of this function?
Y is greater.
Yes, exactly. Y is greater than or equal to 5. Why? Because this is positive. This is because even power, this is positive. I am adding a positive number to 5, so y goes beyond 5. It goes higher. Yes? So now you see why it is important. We never answered this question. Why, when a is positive, we have a minimum, when a is negative, we have a maximum. But now this is the proof. Because if a is positive, this is even power, so this is positive, and this positive number is being added to this number. Whatever this number is, I don't care, but I am adding something positive to it. So y goes beyond this number. And if a is negative, what happens? This part is positive, a is negative, so the product is negative. I am adding a negative number to this constant number. What happens? It goes below that number. So then it becomes y is less than or equal minus d over 4a. And that was exactly the reason. I didn't tell you why, but this is why. If a is positive, y has a minimum value. If a is negative, y has a maximum value. This is the maximum possible value for y, because y is less than or equal to this. This is the minimum value for y. When a is positive, minimum occurs. When a is negative, maximum occurs. That is the proof. You don't need to memorize anything if you know mathematics. Okay, but now let me tell you something. If you can memorize that, of course you can use it. So if I give you y equals to ax squared, I want you to understand. I don't really want you to memorize things. I also appreciate memorizing things, but after understanding this. So everyone realize that another way that I can write this function is this. Okay? And now answer my questions. If I ask you the turning point, can you answer? What is the turning point? So let me write this question here. Y equals to 2x minus 3 to power 2 plus 5. What is the turning point? Yes? Yes, this is the turning point. Yes, so what's the turning point? Minus b over 2a is the x coordinate. What is the y coordinate? This number that you see there. Yes? What is the symmetry line? Yes?
Why is it minus?
Here?
No, the other one. Minus b 2a. Because it says plus there. Turning point.
Yeah, it tells you the plus one, but I want to ask myself when this becomes 0. It becomes 0 when x is minus b over 2a. So the symmetry line is what?
Minus b over 2a.
No.
No,
X is minus b over 2a. Yes? Okay, the turning point is minimum if a is positive. The turning point is maximum if A is negative. So if I ask you what is the range is what? The range is y greater than or equal to minus d over 4a if a is positive. Y is less than or equal to minus d over 4a if a is negative.
Can I take a photo?
Yes, yes.
What level is this?
This is not in your book, but this is not beyond the knowledge. The reason that they haven't given you in the book because they want you to do the process every time. I told you this is good because you understand better every time, but somehow it is bad because how many times you want to understand things? Yeah, you do 2 or 3 times you understand and then use it, yes? At least might be that should be in the formula sheet. Okay, so now let us see finally we can do something or not. Okay, so here we are supposed to minimize this. Okay, but the minimum value is given. What is the minimum value? Minus d over 4a. So I just need to calculate this. Yes, but this is of course still not a friendly number, but it is much simpler than to do the calculations with these ugly numbers. So if I ask you what is t minimum, the minimum value of t is this number. Why? Because a in this case is positive. Okay, so let us be a little bit minus d over 4a. What is d? B squared minus 4ac over 4a. Let us calculate. What is b in my problem? Still it is horrible, you see? So it is minus 4d over 9 to power 2 minus 4 times a, you see, let alone if you want to make the complete square, and then multiplied by c, and then divided by 4 times a. But at least you have it in closed form, you can just put it in your calculator. But if you don't have the formula, you have to every time use the complete square method and then find this. But let us see how we can do. So what happens, by the way? This becomes what? A minus sign is there. This becomes what?
1,600.
1600 over
81.
81. Okay, what happens here? 4 times 35 times 50. It's very simple. Because I don't need to multiply, I don't need trouble for myself. I multiply 4 by 50, it becomes 200. Forget about 2 zeros. Multiply 2 by 35, 70. And 2 zeros, 7,000. Okay, so it is 7,000. Yes? And then I have 9, 9, 81. And then here, 4 times 35. What is that? 140. Over 9. But the good news is that it becomes minus. I can subtract them. What is the answer? 1600 minus 7000. Minus 5400. Minus 5400. There is also a minus sign. It becomes positive 5400 divided by 80. 1 divided by 149. Yes? First of all, I consider the minus. This 0 and that 0 are gone. This 9 and that 1 is simplified. Yes? This 1 by 2 is 7. This 1 by 2 is 270. Oh, I am lucky. 270 by 9 is 30. So 30 over 7 without calculator. Yes.
It's not 540.
I hope that it is 5,400. And there was 140. I dropped the zeros. You understand or not? Yes. But the answer is 30 over 7. And this is something that you even couldn't guess. That the minimum number in this bag is this number. So I cannot go below this number. But the question is not finished. For which values of x and y this smallest value is achieved? For which value? This is the minimum possible number that you have in your bag. Yes?
Y is greater than or equal to 30.
No. No, what is the x and y? You cannot say x is greater. I want a fixed x, I want a fixed y. So do you understand the question? Don't let this is not complicated. It is lengthy and ugly. Oh, it doesn't mean it's complicated. Yes, it's ugly. This is a bunch of ugly numbers. Okay, it is not hard. Okay, because I want to change your perspective about hardness of a problem in mathematics. Okay, so this is the minimum number in that bag. But when I achieve the minimum, for which value of x and y this number becomes that number? How do you answer that?
Maybe is that one the symmetry line?
Yeah, exactly. That is the responsible. To minimize and maximize your function, this number is responsible. This is the minimum or maximum possible value you can achieve. But when I can achieve that by this choice. Is that right?
Yes.
So what is that choice now? X, this is called minimum, this is called the minimizer. The one responsible for the minimum. So the x minimizer is what? Is minus b over 2a. So it's minus, what is b? Okay, another ugly number. Divided by 2 times a. So 2 times 35 over 9. So this is not that ugly because this one and that one are gone. Minus minus becomes plus. 2 and 40 can be simplified. 20 over 35. But can I simplify more? Yes. 4 over 7. So x should be 4 over 7. But the problem is not finished. Don't be happy. Yes? This is x. I want both x and y. So what can I find for y? But that is a simple step. Because y, I hope that you haven't forgotten what we are doing. Y is there. X is this number. I also want to find y. So what is y? Y is 5 over 3 minus 2 over 3 times x is 4 over 7. And this is the last part of the torture, okay? So it's 5 over 3 minus 8 over 21. Take the common denominator. 21, 7 times 35 minus 1 times 8. So what happens? 27 over 21. Can I simplify?
3.
No. By 3, yes, by 3. It is what? 9 over 7. So y should be 9 over 7. It was not possible at all to guess this. It was not possible at all to guess that these numbers are the culprits. They are responsible for minimizing. So if there are 2 questions I want you to understand. One question is that what is the minimum possible value? Everyone answer on the board. 30 over 7. That is the minimum. How can I achieve the minimum? By choosing these numbers. X to be 4 over 7 and y to be 9 over 7. Is that right?
Yes.
Which was not easy at all to see, you know? How many times do you think I can randomly check these numbers so that I can accidentally hit these numbers?
Very good.
Yes.
Let me just.
Is that right? Okay, I think you are confused now. But no, I just want you to feel. This is a simple problem. Yes? I want you to understand, I'm not joking. The hard problems in mathematics are the ones that you don't even know where to start with. Where to start from. It doesn't matter how many hours you think. Yes? But I don't want you to give you, so yeah, this is good. If you can have it in your memory, you can use it in the exam, unless I implicitly mention use the completing a square method. Yes? In that case, you have to use it. But this is the power of algebra. For example, next year, if you want to write a Python code to find the minimum and maximum of it, because for example, after you learned, it is hard for you to do it for these ugly numbers. Then you need to write a code for you so that you can give these numbers to the computer and the computer gives you the turning point. For this one, you need algebra. So you have to do it yourself algebraically once for all. And when you found the formula, when you have the formula, you can program it by Python or any language that you like to. Now, I don't know how many of you know a little bit of programming. So now you can go and write a code based on these formulas that whenever you give these three numbers for the quadratic function in your code, it immediately gives you the symmetry line, it gives you the turning point, it gives you the minimum value, and that is the power of algebra. If I don't do it algebraically, I don't have any formulas here. So how can I do that? I have to do it case by case. So that's extremely important, especially for technique program. You see, there is a very close relation between mathematics and programming. Okay? So that's sorry because of that, but it was not very bad. At least you learned a lot of things. But these numbers, if I want to give, especially for the quiz, and I don't want to give you calculator, I will think about the numbers to be friendly. Okay, so that you can manipulate it in your head. Okay, at least I hope that you understand what is going on. Okay, let me give you a little bit different flavor problem, which is also related. Oh, the time is finished. Okay. Okay, I will write one problem. At least you can think about it. 5 minutes. We have 5 minutes, yes? Yes? Okay, so one problem I will write here, so you can think about it and find it yourself, okay? So I will draw a straight line here. So consider this line. X, 2x plus 3y equals to 1. Or let me write equal to 6. This line, I don't know, if you draw it, for example, might be something like this, if you draw this line, okay? This is your line. And my question is that you pick a point on this part of the line, the black part. Pick a random point here and make a rectangle out of it in this way. Draw a horizontal line, the vertical line, a horizontal line. Then you make a rectangle. How many of these rectangles I can construct? How many of these rectangles I can construct? Infinitely many by changing this point. Yes? For example, I can choose this point and then make another rectangle. Which in this case might be even a square. I don't know. I can choose this one. I can complete the rectangle. So you see that there are infinitely many rectangles. My question is to see what is the minimum possible area of these rectangles. Yes? Yes.
Is it not infinitely small? Because you can just decrease the height infinitely.
Yeah, that's a little bit unfortunate. This is a good problem, except that the minimum possible value is probably 0 by choosing this point. But let us take this point out, okay? And then, of course, we are in trouble, I agree.
0.1. You mean the smallest possible value?
So let us find the biggest possible value. Yes. No, sorry. The smallest possible value you could answer based on your intuition. What is the smallest area? 0. Because if I choose this one, then of course I will have a degenerate rectangle, which is areas. So what is the maximum area? Is that question clear?
Yes.
So I have infinitely many of these type of rectangles. This line has this equation. Concentrate on this part, which is in the first quadrant, and do as I did, and you get infinitely many rectangles. My question is that, what is the area of the biggest rectangle? Yes, that is the question. Yes.
Y is 2 and x is 0.
Y is 2, x is 0. I don't know. So you are saying that, so I know that this point I know it should be 3, and this point I know it should be 2. This is not hard to see, because if you isolate y becomes minus 2 over 3x plus 2, so the m value is 2. How can I find the x-intercept? To find the x-intercept, you have to put y equal to 0 and find x, so x becomes 3. Anyway, I want you to solve this problem. This is similar to the problem. I mean, the most beautiful problem was the one in the book, because it was a practical problem. You really wanted to solve that one. But there are some questions of this type might be in the book as well, or might be of this type. So you want to minimize or maximize a target function. But you can only solve these kinds of problems which are related to quadratic functions. If the function is complicated, it could be the topic of Math 3C and Math 4. But if it is related to quadratic functions, we can always solve.
Well, can you solve it?
What?
Can you solve it?
Yes, I can. It's not, I just want you to think, okay. So let us say concentrate on one of them. This one is, what is the target function here? In that problem, the target function was given to you directly in the text. But here, what is my target? What do I want to maximize? Area. So let us call it A for area. And write a formula for the area. Concentrate on this triangle. Okay? And then say that from here to here is x. I don't know what that x is. And say from here to here is y. So what is the area? X times y. But what is bad about x times y? I told you before. Two variables. I have to get rid of one of the variables. And that is simple, because this point has which coordinates? X and y. But this point is on this line. So the x, y coordinates satisfy this equation. So that is exactly the same thing. It is a simpler problem. So I need to isolate y. I did it. I put it here. So it becomes x times minus 2/3 x plus 2. Yes? And then I multiply this in. It becomes minus 2/3 x squared plus 2x. And this is a, and this is a of x. So that is your target function in one variable. You are done. Yes? So you see there are no minimums in this problem. So that's why the first problem was wrong. I told you the minimum, I realized that is wrong. Yes? This is negative. So it should have a maximum. And by the way, if you have the formulas on the board, it is done. So tell me, what is the maximum? The formula is on the board. The maximum is minus d over 4a. So it is minus b squared minus 4ac over 4a. So what is a in this problem? Minus 2/3. So I have a minus sign there. 4 times minus 2/3. And then b squared, what is b? B is this coefficient, 2. It is 4. C is 0. There is no C here. So I am lucky. This is completely gone. So that's it. 4 and 4 are also gone. Minus minus also gone. So it is 3 over 2. This is your minimum. Okay? So this is your minimum. Which rectangle has the minimum value? So then I need to ask, what is x minimizer? Minimizer, no, maximizer in this case. There is no minimum. Maximizer. So what is x maximizer? Minus b over 2a. So it is minus 2 times minus 2 over 3. What is b? B is 2. So it becomes 3 over 2. Oh, that is very interesting. So the x maximizer is the same as the minimum, the maximum value. And what is the y minimizer? So it means that I have to go to the middle. If I want to make it maximum, where should I go? Middle. Exactly in the middle. And then go upward and then here. Okay, can you predict what this will be? This is not hard. So 3 over 2, I put it here. 3 over 2 is 1. So could you guess? I couldn't guess this before, that this rectangle has the biggest value, area. The rectangle that you have to start here from the middle and here from middle. Okay, so that is the type of problems. Okay, but on the quiz, the problems will be much harder. Okay, so prepare. Yes, much harder. Okay, good luck.